I talked a bit about what the Global Climate and Energy Project is. It's a 10-year, $225 million project sponsored by 4 companies, ExxonMobil, GE, Toyota, and Schlumberger. And our mandate is to look across primary energy resources and transformations of those resources into useful energy forms, and ask where can university-based research help lead to new options for reduced greenhouse gas emissions. So we have a wide-ranging portfolio that includes work that goes everywhere from solar to advanced combustion to biofuels to carbon capture and storage. Today I talked about the opportunities for nanostructured materials that can be put to use in photovoltaic devices that convert sunlight into electricity. They can be put to use in splitting water using sunlight to make hydrogen from water, or in advanced batteries that can where you can take advantage of our ability to make very small structures to store energy more efficiently than we can do with the traditional kinds of batteries we have now. If you look at the available energy resources, they are very large compared to the amount of energy we humans use. We use about 15 terawatts now. The amount of sunlight reaching the Earth's surface is about 3,000 times that. So there's plenty of sunlight, but we have to convert it into something that we can use, and that could be electricity, it could be heat, it could be mechanical work that moves a vehicle, for example. And it's the cost of those conversions that really controls what we do. We also have quite large fossil fuel resources. We can use those in a carbon-constrained world if we can also capture the CO2 and store it so that it's not emitted to the atmosphere. There actually are quite a few resources, but it's all about how we convert those and whether we can do it in a way that makes economic sense. We have a world's energy system that is very large. It provides lots and lots of energy for transportation and heat and lights and all the services that those of us in the West take for granted. But there are also constraints that come from the fact that we now know we need to do something about carbon emissions to the atmosphere. So that changes the game in the sense that we need to either look for more efficient use of energy, we should be doing that anyway, or we need to substitute fuels or energy resources that don't emit carbon, or we need to capture the carbon that would be emitted and store it someplace where it doesn't get to the atmosphere. So there are multiple options available for us to do that, and we have some of the pieces in place now that we need to do that, but there are others that will need additional research in the future. We humans are pretty inventive beasts if we make up our minds to do something, and I'm confident that we can transform the world's energy systems in a way that will do a better job of protecting the planetary systems that we count on for many services. Which is not to say that this won't require lots of hard work. It's going to take researchers. It's going to take companies with global reach that can put all this in place. And it's going to take all of us individuals being a little more careful in how we use energy in the future. But I do think that we can deal with the issues that face us if we make up our minds to do that.